Example 1 here on gradients, tangents and normals is taking a look at finding the tangent. We're asked to find the tangent line of y equals x minus 1 all squared minus 2 at x equals 3 over 2. And we can see roughly what we were asked to find here using this diagram. In blue here we have the curve y equals x minus 1 all squared minus 2, and this red line here represents the tangent line at x equals 3 over 2. Okay, so let's just denote first that this blue curve here represents y equals x minus 1 all squared minus 2. And this red line represents the tangent line at x equals 3 over 2. So what we can see here is this point here is 3 over 2 is 1.5, right? So that's 3 over 2 there. So how would we do a question like this? Well, for a question like this, we need to make use of differentiation. If we're looking for the tangent line here, first we need to find the gradient. And to find the gradient, we can simply differentiate here. Now to start with, we have this form here, which is in terms of a squared expression here, x minus 1 all squared minus the 2. So what I'm going to do first here is just expand this double bracket here and simplify. So in that case, we obtain y equals, that's going to give me x squared. I'm going to have a minus 2x here. I'm going to obtain a minus x and then another minus x. That gives us minus 2x. I'm going to get a plus 1, and we've also got the minus 2. So that's plus 1 minus 2. And if we simplify that then, therefore y is equal to x squared minus 2x minus 1. Okay. So in other words, our blue curve here is this expression, this quadratic. Now, if we want the gradient here, first we need to differentiate this. So therefore, dy by dx here. That means we're going to differentiate y here with respect to x. And if we move along term by term, well, the first term here, x squared, differentiates to 2x. Minus 2x then, the next term here, that differentiates to minus 2. And the minus 1 here, well, as that's a constant, when we differentiate that, we obtain 0. So simply, dy by dx is equal to 2x minus 2. So therefore, what we're looking for here is the gradient at this x coordinate, 3 over 2. So therefore, dy by dx at x equals 3 over 2 is simply obtained by substituting x equals 3 over 2 into dy by dx. So the gradient here of the tangent mt is equal to 2 lots of 3 over 2 minus 2. And in this case, 2 times 3 over 2 gives us 3, minus the 2 gives us a gradient of 1 here for the tangent. Now we're looking for the tangent line. So far we've got the gradient. So what we need now is the form of y equals mx plus c here. So what do we need here? Well, we're going to need a y coordinate. We already have the x coordinate here, that's 3 over 2. So in this case, how would we obtain our y coordinate? Well, we'd simply substitute x equals 3 over 2 into this expression here for y. Okay? And if we do that then, what we obtain for y here is simply minus 7 over 4. So when x equals 3 over 2, y is equal to minus 7 over 4. Okay? So here now, we can use that to work out c. That's the only thing we need now. We have the gradient. This would be in the general form y equals mx plus c, so all we need then simply is c. So therefore, minus 7 over 4 is equal to mx, where m is 1, times by x, which is 3 over 2. So 1 times 3 over 2 here, and we have plus c. Okay, and all we need to do now is rearrange this to be in terms of c here. So therefore, c is going to be equal to minus 7 over 4 minus 3 over 2, because this simplifies to 3 over 2. So we need to subtract that off both sides here. And then in that case, c is equal to minus 13 over 4. And therefore, in that case now, we have everything we need to obtain the tangent line to y equals x minus 1 all squared minus 2 at x equals 3 over 2. Well, in this case now, as this was represented by the red line here, let's represent our tangent line in red. And using this general form here of y equals mx plus c, Therefore, the tangent here can simply be expressed as y equals mx. Well, m is 1, so that's just going to be y equals x plus c, where c is minus 13/4. And therefore, that gives us our tangent. So tangent is given by the following equation. By this equation, y equals x minus 13/4. Giving us the solution to example 1 there. Example 2 here on gradients, tangents and normals is taking a look at finding the normal now. And here we're asked to find the normal line of y equals x minus 1 all squared minus 2, again at x equals 3/2. So this example is quite straightforward because we have a lot of the information we need from the previous example. We know the gradient for the tangent here, this red line, was given with a gradient of 1. So the gradient for the tangent is equal to 1. Now if we want the normal line, that's going to be this green line here. That means the gradients here between the tangent and the normal are perpendicular. So therefore, if these two lines are perpendicular, what that means then is the gradient for the normal, mn, is simply going to be given by minus 1 divided by the gradient of the tangent. And in this case, as the gradient for the tangent here is 1, the gradient for the normal is simply given as minus 1 divided by 1, which is equal to minus 1 there. And therefore, again, in this case, as x is equal to 3/2, if we substitute x equals 3/2 into this equation here for y, we obtain that y is equal to minus 7/4. Okay? So in that case now, all we need to do is use y equals mx plus c now. We have our x and y coordinates here. We have our gradient of minus 1. All we need is c, and we've got our normal line. So therefore, substituting everything in appropriately here, we obtain minus 7/4 is equal to mx, where m is minus 1. This is minus 1 times x, which is 3/2. And we have plus c here. And again, we're just rearranging this now to be in terms of c. So therefore, c is equal to 3/2 minus 7/4. And in this case, 3/2 minus 7/4 simply gives us minus a quarter there, minus 1/4. So therefore, the equation of the normal represented in the green line here. So let's represent this in green pen then. So therefore, equation of the normal line again using our general form here of y equals mx plus c. So the equation of the normal is simply given by y equals mx plus c. Well, m is minus 1, so that's going to give us minus x, and our plus c here is minus 1/4. Okay, and that gives us the equation of the normal, and that gives us the solution to example 2 there.